Okay, so let's start. Okay, so last time we have discussed some terminology. Okay, and we have also take one example. Okay, to understand all that terminology. Okay, so today we will discuss. Okay, in depth. Okay, the types of reinforcement learning also. Also, we will discuss Markov decision process. Okay, and I think we have discussed regarding observable environment and partially observable environment. So I think is it discussed or not? Can just confirm in question answer window. So I can do accordingly. Types of environment we have discussed or not? Okay. So I think it is not discussed. Okay, so let's discuss first that. Okay, so I think already you know about the environment. Okay, and whenever you are considering the environment, okay, so there is two types. Okay, first one fully observable environment. Okay, and second one is the partially observable environment. Okay, so here I'm writing. Okay, so you can understand properly. So types of environment. Okay, and first one is the fully observable. Okay, and second one is the partial observable. Okay, so there is two types. So I can take one example of Mario game. So I think already you know about the Mario game. Okay, and whenever you are starting Mario game, okay, to play, then you can see only limited okay part of the game is visible to you. You don't know. Okay, whenever you are not going okay forward direction, you will not don't know. Okay, that what is the what will be coming. Okay, if you are playing one time, then you can know that. Okay, but first time if you are playing, okay, you don't know the full game and full game strategy also. Okay, so this is called the partially observable. Okay, you can't observe fully here, so you will not know that what will the reward you will get. Okay, miss what will the you can say result. Okay, whenever you are doing action. Okay, to the current that visible part. Okay, so this is called partially observable. Fully observable means you will know that all the games, all the things, everything. Okay, you can know here. Okay, so you can consider many games are available. Okay, like I think Counter Strike. Okay, so here you know all the maps and everything you are knowing here. Okay, so all the environment is fully observable, but you don't know. Yes, chess is also fully observable. Yes, good Nishan. So many games are available which is fully observable. So you know everything here. Okay, and you can also predict here. Okay, but in partially observable you can't predict in environment. Okay, so what is the environment here? Huh? State that environment can give reward that environment can give. Okay, so this is the part of the environment state and state transition reward. Okay, so from the environment you can get this. You can expect that. Okay. So here we can discuss two more terms like exploration and exploitation. It is very useful whenever you are considering the active reinforcement learning. So there are two types of reinforcement learning. Okay. So here I can write. Okay. So types of reinforcement learning. Okay, so first one is the passive reinforcement learning. We will also discuss the types of agent also. I think there are many types of agent, but we will discuss only basic things. Okay, so here this is the passive reinforcement learning, and second one is the active reinforcement learning. So we will discuss this thing also. So first we have to discuss the exploitation, okay, and exploration. Okay, so understand carefully for this. Okay, now, so what is the exploitation first we will discuss. Okay, so what is the exploitation? Okay, so let's take example like you are going to new city. Okay, and you don't know about the restaurant. Okay, and you want to eat the food. Okay, so at that time you will search one restaurant, and you will find one restaurant. Okay, and you are going that restaurant. Okay, and you find that okay, it is very good food here, and every time you are hungry. Okay, so at that time you are going to that same restaurant every time. But there are more restaurants also available in that city, but you are not going because you are trusting on that restaurant only, and you know that quality of food, okay, is good in that restaurant. Okay, so what is the thing here? Maybe there are possible uh, best restaurant than that. Okay, restaurant is available. Okay, in that city. Okay, so you don't know about the other restaurant. Okay, you are believing that this is the best restaurant. Okay, and you are every time you are going to that restaurant. So what is the thing here you have to understand for reinforcement learning? Okay, so take the current best action. Okay, so you can take the current best action in the current situation every time. Understand carefully. You have already taken the best action. Okay, so you will know that this is the best action for this current situation. And every time the situation will occur, okay, you will take same action every time. Okay, maybe there are possibility like there are other actions also available which can be more than best of that action, but you will not go to that action. Why? Because you know that this action you are taking now, okay, it is the best action because of the past experience. Okay, so according to past experience, you are taking the action. Okay, so this is called the exploitation. Okay, in reinforcement learning. So second one is the exploration. Okay, so taking risk. See, so exploration is the taking the risk. Okay, we can take example of the restaurant. Okay, so you are going to that restaurant 2 to 3 times. Okay, and then you will think that let's here there are one restaurant also available. Let's check the food. Okay, and let's eat it. Okay, so you can go that restaurant and you can check that. Okay, so you are taking the risk here. Okay, maybe that restaurant can be bad. It can be more good than that restaurant that you have visited. Okay, so maybe it is possible both the things. Okay, so there are two possibilities available here. Okay, so you are taking the risk. So here in exploration, we are taking risk once in a while. Okay, and it will help to finding the action which might be better for the current state. Might be, huh? It is not compulsory that we are getting every time better result. Okay, but we are going to find other restaurant also. We are going to find other action also in reinforcement learning. Maybe we can get the more better action. Okay, or maybe we are not getting the more better action. Okay, but based on the past experience, we have already one best action available. Okay, so we are satisfied that. Okay, in exploitation, but in exploration we have that best action available. Okay, and we are also finding other best action. Okay, more than that. Okay, we are finding. Okay, so this is available in exploration. Okay, so anyone have any doubt regarding exploration and exploitation? Then tell me. I think it is very uh, uh, easy to understand by using this example restaurant. Okay, so anyone have any problem? And if you want to write for exploitation, you can write down that take the current best action. So I'm writing here. take the current best action, okay, in the current situation every time. Okay, so this is called the exploitation. Okay, and here I'm considering the exploitation now. Okay, so in exploitation we are taking the risk. Okay, so taking risk once in a while, not every time, once in a while. Okay, and also we can say that it helps to finding the action, okay, which might be better, maybe better, okay, for the current situation. Okay, understand here. Can anyone tell me what is the state here? See, whenever we are talking about the reinforcement learning, okay, so we should know the some parameters here. What is the state here? Can anyone tell me? Because we are taking the action, no? So what is the state here? Anyone? Write down in question answer window. If you don't know, so you can write down don't know, but at least you can write. Okay, Rishabh, my question is here. We have discussed exploitation and exploration here. Okay. So my question is like that. We are discussing according to the reinforcement learning. Okay. So what is the state? State. I think you know about the state. Okay. So this exploitation and exploitation, we are talking about the environment here. Okay. So just tell me what is the state in this definition of exploitation and exploitation. If you are understanding properly this exploration, then and then you can give the answer. Yes, Nishant, good. Any other student? Yes, maybe. Yes, good. So already we have discussed the reinforcement learning is time based. Okay. So already we have discussed the ST and ST plus one. Okay. So both things are true. Okay, Nishant. Other students also you can try. Huh? No one? Okay. So here you can see current situation. Okay. So what is this current situation? It is the ST. Okay. This current situation is the state. Okay. And we are taking the action onto that current situation means ST and we are getting new ST plus 1. Okay. Means next situation we are getting here. Okay. By using that action. Okay. So understand carefully. How can we decide what is the best action here? Huh? Can anyone tell me what is the mapping between state and action? Can anyone tell me? Because we are talking about the state and action here. Already we have discussed regarding map of state and action. Okay, and what is that terminology? Terminology we have discussed, no? Regarding the state and action, and we have mapped the state and action. Okay, so what is the name of that terminology in reinforcement learning? No, Nishant, no hate. I think no, it is not like that. Yes. Mm, okay, I'm repeating question. So here you can see in one terminology we have discussed, okay, that we have map, action and state. Just give me the name of that terminology. No, Shivam. Okay, so I think all of you forgot. So let's discuss that terminology. Okay, this is called as policy. Okay, and understand carefully. Policy actually map from state to action. Already we have discussed that. Okay, like we have discussed action A is equal to pi s. Okay, this is the function of policy. Okay, and here policy takes the input here state. Okay, and it will give you the action. So here, what is the expression exploitation? Okay, taking the current based action. So what is the meaning of that? Taking the current based action means we have one policy, okay, and that policy will give you the action here according to the situation. Situation is state. According to the state, okay, we are getting the action here. Okay, so this action, okay, is chosen by the one policy. Understand carefully. Okay, so for that policy we are discussing here exploitation and exploration. Understand carefully. Okay, so this is the policy. Both the things are policy here. Okay, so why we are discussing this exploitation and exploration? Because in passive reinforcement learning and active reinforcement learning, it is very important. Okay, without this understanding, you can't understand this what is the passive and what is the active reinforcement learning. Okay, so what policy do? Policy takes the input here state, okay, and it will decide. Means policy will decide what will be the action we can take here. Okay, and this is the uh, thing which decides the agent behavior. Okay, understood or not? I can repeat this thing. Huh? See, every time I am asking the question that you have understood or not. Okay, because I can understand that. Okay, whether I have taking that example is good or not. Okay, okay, Rishabh. Okay, Rishabh. So I can repeat it. So what is the policy? Hmm? If you want to write, okay, the definition of the policy, so you can write down the definition. Policy is a map from state to action. Okay, so we are deciding action. Okay, here in this policy. Okay, by taking the input here state. So action we are deciding according to the current situation. Okay, in policy. Okay, so there is two type of policy. Fixed policy is also there. Okay, and there is no fixed policy is also there. Okay, and we will discuss that thing also. Okay, this dynamic policy also we will discuss. Okay, so both the things we have here. Okay, so understood carefully. Policy is a map. Okay, from state to action, and it can decide the agent behavior. Okay, yes, we can say the policy can be the rules of for action. Okay, but for that we need the state. No, output of the policy is the action, not the new state. See, here you can see this is the policy function. Okay, so policy function, name of this policy function is pi. I can't write pi, just a minute. I can draw it. A is equal to pi s. This is the, you can say, this is the policy function. Okay, pi is the policy function. So I think you already know about the mathematical function. No? The mathematical function, like you know about this fx. Okay, like x square plus 1. So if you are taking x is equal to 1, okay, then you will get 1 plus 1 is equal to 2. Okay, so understand carefully. What is 2? 2 is the action. What is 1? Is the state. Okay, So pi is the policy, okay, policy function, okay, and S is the state, and A is the action. Okay. So what is the output here? A, output. S is the input. Okay, Rishabh? So that's why I have discussed this policy function before. Okay, and at that time also I have explained this state and action, and at that time also I have discussed what is the input and what is the output. So whenever I'm discussing any function, mathematical function, okay, understand carefully. Whatever I'm writing inside this bracket, it is the input. Okay, and outside of that bracket, near to the equal sign, it is the output. Okay. So any question regarding this now? Anyone have any question? Best to understand the policy, huh? Otherwise it will be very difficult because I will take one example today, okay, to discuss everything like policy, state, transition, many things we will discuss. Okay, reward also. Okay. So anyone have any problem regarding this? Okay, good, good. Okay, so let's discuss what is the passive reinforcement learning. Okay, so in passive reinforcement learning, you have to understand agent policy is fixed here. Okay, so let's discuss with the types of agent first. Then we'll discuss the passive reinforcement learning, okay? And then we can discuss the active reinforcement learning. So I'm just erasing this. Okay, so here types of agent. Okay, so here we can again see utility based agent. Okay, so first discuss this utility based agent. Okay, so here utility based agent, okay, must uh, have model of the environment. Okay, so already we have discussed the model of the environment. So in order to make the decision, so who make the decision here? Agent. Policy is for agent only. Okay, so policy. So what is the input in agent? Reward. Okay, state. It is the input in agent. Okay, and what is the output from the agent? Action, which is going to the environment. Okay, so here understand. If you have one agent, okay, so why it is utility based? Because whenever you are getting reward at particular step, okay, so maybe it is possible that sequence of decision you have, okay, means sequence of actions you have made, okay, for that environment. So already we have discussed that sequence of the action. Okay, what is the name of the terminology? Can anyone tell me? Sequence of that action we have taken. Okay, in Pong game we have I think written that up down up down up down, that action sequence of that action. Okay, and maybe it can be win, it can be lose. Okay, output of that sequence of the action. Okay, so can anyone tell me what is the terminology for that sequence of action? Can anyone tell me? Yes, good, Prashant. Good. Other students, write down in question answer window so I can know that you have attended my lecture properly. See, that's why I have discussed all the terminology. No zeal, it is not the Prince. What is years? I don't get meaning of the years. Okay, Mano, my question is here. If we have sequence of action, okay, so what is the name of uh, that particular thing? Like here we have defined the policy, no? So similarly, just define that sentence like sequence of action. Okay, so what is the one name of that? And also I have discussed regarding Pong again. like sequence of action. Here we are taking up, down, up, down, up, down, up. Okay, and at the end of that sequence, we are getting the result like we won or we lose. Okay, so you can decide uh, by that sequence of action. So what is the name of that sequence of action? You can tell. Only Prasad give the answer properly. No one, just you can write down in question answer. If you don't know, then you can write down. So I can explain again. Don't worry. No, Nishant. Reinforcement learning terminology is different. No, Rushabh. No, Nishant. No, it is not. Okay, okay. Let's discuss. So whenever you have okay a list of action. Okay. So why we are using the terminology. Okay. So here you can see sequence of action means you are taking actions. Okay, sequentially. First you have take the up, then down. In Pongi game I am discussing. Okay, so keep in mind that I am discussing whatever here. Okay, so it is regarding Pongi game. So here up and down we are taking the action up, 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 down, 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 then up, down. Okay, according to the ball position we are discussing here. Okay, and we are keeping the weight position according to that. Okay, so sometimes we miss the ball, sometimes we hit the ball. Okay, and opponents can miss. Okay, so here you can understand. Okay, according to that you will get the rewards every time you are getting the reward. Okay, whatever sequence of action you are taking. It is not like that you are taking up and directly you are getting the reward. No, reward you are not getting directly. Okay, whenever you are doing the sequence of action and then after 5 to 10 action or 20 to 30 action you are taking, then after you are getting the reward. Okay, so after getting that reward you can know that this is the best action sequence of action. Okay, and we can take every time. Okay, and this is the not the best action. Okay, we can't take. Okay, and we can't do the mistake. Okay, next time. Okay, so how can we decide? By using the sequence of action, no? Okay, and the result of that action, sequence of action. So we can decide that okay, this is the sequence of action which is good and which is not good. Okay, so here this is called the episode. Okay, sequence of action. It is called the episode. Okay, and in every episode, okay, we can get the reward here. So see, every time I'm speaking sequence of action, it is not the good. No? So that's why we are using the terminology here. Okay, like you can understand that what is the episode here. Okay, so episode is the sequence of action, and whatever we are getting the reward. Okay, in that episode. Okay, according to that, our reinforcement learning will take the next sequence of action. Okay, so understand carefully this terminology. Okay, so let's discuss here first of all utility based agent. Okay, so this utility based agent, okay, have a model of the environment in order to make decision. Okay, because it must know the state to which its actions will lead. Okay, so here we are taking one example. Okay, in order to make use of, I think many of you know about the game Bake Game On. Anyone know the game name Bake Game On? I'm writing here. Anyone? If you don't know, then you can consider chess game also. Okay. But in chess game, strategy is different. In game on game, strategy is different. But yes, we can say that in both game, okay, different rules are available. Okay, and you can consider the chess game also. Okay, just we are discussing the general things to understand the utility based agent. Okay, so whenever you are take one example of this chess game or this back game on game. Okay, so you will have what evaluation function. Okay, that evaluate that whatever your movement is doing. Okay, so it is best or not. Okay, and according to that you can get the reward. Okay, so here understand carefully. Okay, to make use of that evaluation function. Okay, that whatever game you are considering. Okay, you have to write the program. Okay, that program must know what its legal move. Okay, sometimes we can't move that particular chess that part of that game, na? Okay, like queen or many parts are there available in chess game. Okay, so there is restriction of each and every part. That one part can move only one step, one part move diagonally only. Okay, so what is the legal move we can take? Okay, in that particular thing. Okay, so in order to use of evolution game, program must know, okay, what is its legal move and how it will affect the board position. Okay, and what is the last reward that you will get. Okay, so only in this way, okay, can it apply the utility function to the outcome states. Okay, so anyone have any questions regarding utility based agent intelligence? And here you can see utility. Utility means you can say the total reward that you are getting. Okay. See, whenever you are considering the chess game versus Pong game, so at that time you can compare like in Pong game you are getting every time the reward, but in chess game you are not getting any reward here. Okay, at the last means at the end of the game you will know that whatever movement, okay, sequence of movement you are taking, okay, is it good or not. Okay, at the end of the game you will know that. Okay, but here utility based agent, okay, will calculate that thing. Okay, understood or not? Utility based agent. Okay, okay, so let's discuss a second type. Okay, so here I am writing here Q learning agent. Okay, so here we will discuss again policy. Okay, and according to the policy, okay, so you can understand how can we combine exploration and exploitation to choose an action. Okay, so for that we can use the greedy policy. Okay, so already you know about the greedy technique. Okay, so whenever you are using epsilon, okay, that we have discussed the gamma value. Okay, so we can discuss here also. So here epsilon greedy policy combines both exploration and exploitation. Okay, and in that, okay, two functions are there. In that, two functions are there. One function is the value function. So already we have discussed the value function, and second function is a q function, and that q function takes two things, action and state. So already you know about the value function. So it represents the quality of that state. Okay. So it will give you the value. Okay. So what is the quality of that state we can decide here. Then second one is the Q function that will understand carefully. That will take the two things, state and action, both the things. Okay. Will take the input. Okay. And give the output. Okay. Quality of that action in that state. Okay, so it represents, this function represents the quality of that action. Okay, of that action in that particular state. Okay, so let's take example. I think you can't understand directly. let's take example. One situation is there, okay, and we can apply three possible actions. Like you can take one example, robot, okay, and you can take three actions. Like you can take example up, down, and left. Okay, so three action you can take. Okay, so how can know that that which action is best? Okay, and which action we have to take? So according to this Q function, we can decide. Okay, according to that state means current state and that action. Like we can take one action like up. Okay, and we can generate the value. Okay, so how can we generate the value? By using the Q learning algorithm. We will see that algorithm also if we have time. Okay, so by using that Q learning algorithm, we can generate the value. Okay, that action according to that action. Okay, and the current state. Okay, so if you apply that action, okay, into that particular state, what will be the value that you will get? Okay, so it will decide by using the Q function. Okay, so here Q learning algorithm is very useful, okay, to decide this Q function. Okay, so that's why we will discuss this Q learning agent. Okay, so in this Q learning agent, okay, can compare the values of its available choices without needing to know their outcomes. Okay, so it will not know about the outcomes. Okay, so without needing to know their outcomes, so it does not need a model of the environment. Okay, so there are no need to understand what is the model of the environment. Okay, and that agent don't know where the action leads. Okay, few learning agents cannot look ahead. Understand carefully. If your current state, okay, you can say ST, okay, so after ST, what like what type of reward or what type of states will generate that Q learning agent will don't know. Okay, don't know. Okay, anytime that what will be the future will be. Okay, you can just know that about the action on that particular state only. Okay, so anyone have any problem regarding Q learning agent, Q learning function, or value function? Okay, that we have discussed regarding policy also, and also see, this is also, you can say, the epsilon greedy policy. Okay, and inside that we can use this Q function. Okay, so if you have any problem regarding this, then you can discuss with me. Any problem? Okay, okay. So let's start with the third agent. It is very easy. Reflex agent. Okay. So here I am writing. Okay. Reflex agent. Okay. So this reflex agent learns the policy that maps directly from state to action that already we have discussed. So you can say that this is the general agent, okay, that we are considering, okay, in all over the reinforcement learning. Okay, mostly we are considering this reflex agent, or sometimes we are considering this utility-based agent, okay, to use utility function. Okay, so we will see all the things, utility function and policy iteration, value iteration, many things are available. Okay, so we will see, okay, that thing. Okay, so reflex here agent, okay, learns policy. Okay, reflex agent learns policy, and according to that policy, it will map from state to action. Okay, so what is the you can say meaning of the agent? Agent will take the state and reward as the input, and it will take the action on the environment like player, okay, of the game. You can say, so you can keep in mind, so you have one policy, okay, and according to your policy it will take the action. Okay, so this is called the uh, a reflex agent. Okay. So here we can discuss passive learning. Okay. So here agent's policy is fixed. Now you can understand here. Okay. And the task is to learn utilities of states. What is the here utility of state means state action pair. Okay. So we are mapping the state and action. Okay. So we are learning here. Okay. So what is here in passive reinforcement learning? Agent's policy is fixed. Okay, you will not change the policy. Like here, according to exploitation, you will not change the policy. Whatever best action you are taking, according to that best action, you will take every time. Their same actions you are taking. Okay. So here, understand carefully. So it will learn the utilities of states. Okay, means you will have mapping of state and action. Okay, and you will just take according to that. Okay, and this could uh, involve learning a model of the environment also. Okay, okay. So anyone have any question regarding passive learning agents? Then tell me. We will take one example for that, but today we have no time. But in next lecture, I will take example for passive learning, and we will discuss that. But before that, see, uh, passive reinforcement learning is means see whenever you are discussing this passive reinforcement learning, you should know the policy and utility. Okay, some terminology you should know. Okay, and for that you should know about the fully observable environment also, and for that you need Markov decision process also. So first we will discuss the Markov decision process, some terminology also. Okay, and one example inside Markov decision process. Okay, and then we will discuss the passive reinforcement learning. Okay, and in active reinforcement learning, we will discuss the Q learning algorithm. Okay, so already we have discussed this Q learning agent. Okay, so this thing also we will discuss in active reinforcement learning, and exploration you can say can be applied in active reinforcement learning because policy is not fixed inside active reinforcement learning. Okay, and policy is fixed inside passive reinforcement learning. But here, passive reinforcement learning only apply on the fully observable environment, and active reinforcement learning can be applied in partial observable environment also. Okay, so this is the thing that I have discussed in this lecture. Okay, so anyone have any issue regarding this? Then you can discuss with me. Anyone have any issue? No issue, no? Okay. So I am asking the question and just give me the answer. What is the goal in reinforcement learning? What is the actual goal in reinforcement learning? Good, Shivam. Good. No, Nishant. There is no need to connect with neural network. Okay. We can apply. Okay, we can combine both two parts. Okay, but yes, Rishabh, good. Yes, head, good. See, today we have discussed many things, and I am slowly moving to some complex part. Okay, so be careful whenever I'm explaining any definition or any terminology. Okay, so be careful. Okay, 58 head. Maybe we can say. Yes. Yes. Now it is correct. So I think many of you get this particular part, reinforcement learning, types, also policy, also agent, also. So I'm thinking that it will be easy. So whenever we will discuss one example of that, okay, so it will be very easy to understand. Otherwise, uh, it will not understand it. Okay. So okay, let's. If you have any question, you can ask me. Okay, and we will discuss other topics in next lecture.